here is an example for our similarity, our angle-angle similarity postulate. So the question is, are these two triangles similar? So let's first of all compare the given position. So is R congruent to V? Well, I'm not really sure. We don't have any information there. Oh wait, we do. Here's some information. So here's the fact that those two, R and V, are both 45 degrees. So angle R is congruent to angle V. So we just need one other angle, but all that's given is here in the picture. So you have to use some information just from this image to realize, okay, these two angles are called vertical angles. That's something we learned in Unit 1, and vertical angles are congruent. So that means angle WSR is congruent to angle VSB. And now, because we have two pairs of angles that are congruent, we can say, yes, we do know that these two triangles are similar. Next, we have two more theorems. We have theorem 7.1 and theorem 7.2. So we just did postulate up here at 7.1, and now we have theorem 7.1, which is going to be called the side angle side similarity. Side angle side similarity theorem. Or SAS similarity. There we go. And again, we're going to break this down a little bit. So in words, if an angle of one triangle is congruent to an angle of a second triangle and the sides that include the two angles are proportional, then the triangles are similar. So if an angle of one triangle is congruent to an angle of another triangle and the sides that include the two angles are proportional, then the triangles are similar. So in pictures we have, so if we have two triangles again, and we'll name those ABC and QRS. So if AB compared to QR is equal to AC compared to QS, and right, so we have these two sides of the triangles we have talked about being congruent. And then it mentions the included angle. So the angle that is here needs to be congruent. So angle A is congruent to angle Q. Then we can say triangle ABC is similar to triangle QRS. And just like we talked about above with these angles needing to match up, the side lengths also need to match up. So AB is right here, and QR is right here. Right? So we also have AC. I wrote ABS. So AC, notice A and C are the first and last letters. And Q and S are also the last letter. So those are in the same positions. So things match up, and then A and Q, again, A and Q would be in the same positions, and those angles are the ones that are congruent. So the naming is super important. So that's the side angle side similarity theorem. The next theorem is called theorem 7-2. It's the side 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 similarity. So side 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 similarity theorem. You could guess to shorten that, we just use SSS on our swiggle line there. And in words, the theorem says if the corresponding sides of two triangles are proportional, then the triangles are similar. So if all corresponding sides of two triangles are proportional, then the triangles are similar. And a picture. So we have one triangle, another triangle, and label those ABC and QRS again. And what we need to be true in order to claim side, 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 we need AB compared to QR. So AB compared to QR to be equal to AC compared to QS to be equal to BC compared to RS. So if this is true, then we know triangle ABC is similar to triangle QRS. So those are your two new theorems. A couple of examples coming in the next video.